Well, hello once again, everybody, and welcome to another Sun Devil Learning Labs presentation from Arizona State University. I'm your instructor, Michael Barker, and we're down to almost the last couple lessons in our session this hour. So we're going to start with a review. This will be our part one review, and our objective is really going to be to solve and create fraction word problems. We'll talk about a few things that we usually have to go through when we do our lessons. And one, I want to make sure that you're in a comfortable setting with no distractions. That means if you have a little brother or sister running around, or a dog, or the TV on, you want to make sure that your parents can help you, or a responsible adult, whoever's in charge, eliminate those distractions or provide you a quiet place to work. Your learning process will be better, and you'll also be more efficient and finish the lesson sooner. Second, gather any supplies you might need today. I suggest a couple of pencils, a notebook. Hopefully you've got a notebook you've been keeping for the series. At least several sheets of paper, if not. Scissors and a ruler. A ruler will definitely be helpful for drawing lines and tape diagrams and so on. Finally, be sure and use the restroom before we start. But remember, you can always pause the video if you need to take a break. But more importantly, if maybe you didn't understand something and you want to go back and review, you can always slow it down, go back, and recheck your work. Finally, I'll remind you again, we're going to solve and create fraction word problems today. But first, I want to begin with just a practice worksheet. It's going to be some simple multiplication of fractions, just some repetitive practice that hopefully by doing this, you'll get comfortable doing these and you won't have to maybe be pulling out multiplication charts all the time. So take a couple of minutes, work on a sheet, and it will come back and I'll go over a few parts of it with you anyway. Okay, we're back, and hopefully you can check all of these, put your sheet next to the screen or however you want to do it. I'm not going to go through them all. A couple that I did want to point out to you, though, that you had to simplify them, or you should have simplified them. You know, the 6/12 is the same as 1/2, 2/18 the same as 1/9. And then on the other column, we had a couple of times where, like the last one, 12/9 is really the same as 4/3. And I did not change it to a mixed number, but hopefully you know that's also the same as 1 and 1/3. And I don't know if I thought there was another one here where we had something that would, yeah, 18/16, the same as 9/8. And if we change that to a mixed number, it would have been 1 and 9/8. So if you did it that way, that's fine. And if not, just so you know that you got to multiply numerator times numerator, denominator times denominator, and then if you can simplify, you simplify. And that's really about all it is. I'll leave this up for a little bit for you if you're not done looking at it or working on it. And then when you come back, we're going to get ready to start just a few problems because we are going to focus on our word problems today. So here's our first problem. It's kind of a typical problem of what we've been going through. And we have a tape diagram. We know that the whole is going to be the sum of 8 and 3. It's asking us how much one of these 3 equivalent parts would be. So what they want us to do now is answer these questions. What is the whole? To try and write an expression that describes the diagram, and then finally solve the expression. This should only take you a couple of minutes. Take 2-3 minutes, fill in the answers, and then we'll go over them in the next slide. All right. Hopefully you could have answered the questions, and your sheet should look something like this. 8 plus 3 is 11. Our whole is equivalent to 11. And then it said write an expression that describes the diagram. It's 8 plus 3, the whole, divided into 3 parts, right? 1, 2, 3. So when we solve the expression, 8 plus 3, broken into 3 parts, 8 plus 3 is 11, so 11/3, and we can convert that to a mixed number. 3 is the same as 9/3, and we have 2/3 left over. So your expression solution should look something like this. Here's Here's your improper fraction, and this would be the mixed number. And that is equivalent to what our question mark would be, right? Each part would be 3 2/3. Here's another one we're going to match to the diagram. Take a couple of minutes. It's just going to be a different expression. Try and write your expression first this time, then solve it, and then finally your solution will be, you'll be able to tell me what the whole is. Okay, take a couple of minutes and then we'll come back to it. All right. First part, write an expression to match the diagram. Well, what do we know? We know 1/2 and 1/4 is equivalent to one of 3 parts. So 1/2 plus 1/4 multiplied by 3 is an expression that describes the diagram. I probably should have wrote equals question mark, but that's what we have. And then when we solve the expression, we know 1/2 is equivalent to 3/4. At times, or I'm sorry, 1/2 plus 1/4 is equivalent to 3/4. 2/4 plus 1/4 is 3/4. We're going to multiply that by our 3 total parts, and we wind up with an improper fraction, 9/4, and we wind up with a mixed number of 2 1/4. So our whole would be 2 1/4, and each part we learned would be, what did we say? 3/4. 3/4 plus 3/4 plus 3/4 would give us a final total of 2 1/4. Your sheet should have looked something like this. And really, by now, you should be able to just write the expressions and not even have to bother with the tape diagrams once you know what the factors are. So let's move on to our word problems. Each one of these word problems we're going to go through. We're going to take our time and try one. I'll give you a few minutes to do it, and then I'll come back and give you the solution. We have 5 word problems total today. And this first one, Kim and Courtney share a 16-ounce box of cereal. By the end of the week, Kim has eaten 3/8 of the box, and Courtney has eaten 1/4 of the box of cereal. So what fraction of the box is left? This will probably take you maybe 4 or 5 minutes to come up with a solution. Go to work. Whenever you're ready, the next slide will be the solution, so we'll move to that when you're ready. All right, here we go. I highlighted a few things. I highlighted the question we're answering. What fraction of the box is left? That's what we're trying to figure out. What do we know? We know that they shared a 16-ounce box of cereal. We should know that's our whole, okay? And then Kim ate 3/8 of the box, and Courtney has eaten 1/4 of the box of cereal. So I showed 2 different methods of solving it. Hopefully your sheet looks like one of these methods. You may not have used them both, and that's okay. If you were ambitious and you wrote them down, that's all the better. But let's look at method 1. Kim ate 3/8 of 16 ounces. We can simplify these fractions, right? 8 and 16, we can 8, 1/8, and 2/16. So now we have 3 multiplied by 2 is 6, and 1 multiplied by 1 is 1. So we know Kim, she ate 6 ounces of cereal. Courtney, on the other hand, she ate 1/4 of 16 ounces. Again, we can simplify our fractions because 4 times 4 is 16. So 4 simplifies to 1, 16 simplifies to 4. You should know a lot of this from our practice simplifying fractions. So 1/4 of 16 is 4 over 1 is equivalent of 4 ounces. So we know that 6 ounces plus 4 ounces is equivalent to 10 ounces. And so now we can draw a tape diagram. We know our total was 16 ounces. We know they ate 10 ounces. And we know the question is how much cereal was left? Well, simply put, 16 minus 10 is going to give us the remainder here, which is 6 ounces. Now, there was another way to go about solving this problem as well. We could have just added what they ate. They ate 3/8 and 1/4. So they ate 3/8 and plus 2/8 because 1/4 is equivalent to 2/8. So now we have like units, and that's 5/8. We know they ate 5/8 of the box of cereal. So if the whole box was 8/8, they ate 5/8. What's that tell us? 3/8 was left in the box. But I wanted to know our answer in ounces. So we multiply now 3/8 of 16, 3/8 times 16 over 1. Again, we simplify. 8 can go into 16 twice. So now we have 3 multiplied by 2 is 6. 1 multiplied by 1 is 1. Equivalent fraction is 6 over 1, 6. There were 6 ounces of cereal left in the box. 6 ounces of cereal left in the box. I hope you can see there's more than one way to solve the problem, and either way is acceptable. And you might have even had another way that probably worked based on some of the other stuff we talked about as we went through the class. Okay, let's look at our word problem number 2. Hopefully you got a feel for the first one, kind of simple, but maybe they're going to get a little more complicated as we go, but you may not think they're complicated if you paid attention and you mastered all the previous lessons. Anyway, Matt has 20 pints of green paint. He uses 2/5 of it to paint a landscape and 3/10 while painting a clover. He decides that for his next painting, he will need 14 pints of green paint. So how much more paint does he need to buy? Again, take a few minutes. Hopefully you'll figure it out now. You use our cubes method, highlight a few things in the question, and then we'll move forward. And when you're ready, 4 minutes or so, solve the problem, and we'll go over our solution. And welcome back. I actually was able to come up with 3 different methods to solve this problem, and you hopefully recognize one of them, or use maybe 2. First, the question is, how much more paint does he need to buy? Now, what do we know? He started out with 20 pints. He used 2/5 of that while painting a landscape, and 3/10 while painting a clover. So, and we know he needs 14 pints to finish his next project. So let's look at what we did in method 1. So again, we know he used 2/5 of 20 ounces for the landscape, and he used 3/10 of 20 pints for the clover. So first, let's say 2/5 of 20. We simplify. Again, 5 goes into 24 times. So now we've simplified. 2 multiplied by 4 is going to be 8. 1 multiplied by 1 is 1. So we know he used 8 pints to paint the landscape, right? And then for the clover, he used 3/10 of 20. So now we have to remember our units are tenths, but 3/10 multiplied by 20. So tenths and 20 simplify. 10 becomes 1, 20 becomes 2. And because 10 times 2 is 20, so now we have 3 times 2 is 6. 1 times 1 is 1. So we know he used 6 pints of green paint to paint the clover. So he used a total of 8 plus 6, 14 pints. And what did he have left over? Well, he started with 20. He subtracted the 14 he used, so he still had 6 pints left over. But the question was, how much more does he need to buy? Well, we know he needs 14 more pints. We know he has 6 left. Simple problem now, right? 14, we'll subtract the 6 he has, means 8 pints. He needs 8 more pints of paint. Okay, let's look at another method. We know that he used, this is method 2. This is where I didn't have to really draw a diagram or anything because I just added what he used. He used 2/5 and 3/10 of his total. We want to make like units, so we change that to 4/10. 2/5 is the same as 4/10. Add that to 3/10. Now we know he used 7/10 of the paint. So 7/10 of the 20 pints that he started with, we can multiply 7/10 of 20 over 1. Again, we simplify 10 and 20, that becomes 1, that becomes 2. 2 multiplied by 7, 14 pints were used. That's what we found out earlier, but again, we can go over how this solution might have looked if you only did it one way. So he started with 20. He subtracted the 14 pints he used. That left him 6 pints. He needs 14. He has 6. So it tells us he needs 8 more pints to paint the next painting. Finally, we had method 3. If you wanted to use a tape diagram, we know that 2/5 is the same as 4/10. So since we can break our tape diagram, we can break our 20 units into units of tenths. We know the land was 1, 2, 3, 4/10 of paint. And then the clover, he used 1, 2, 3/10. So what did he have left? He had 1, 2, 3/10 of the 20. So 3/10 multiplied by 20, you should have had 3 multiplied by 2 is 6 over 1. Again, our math, he started with 14. He needed 14. The 6 that he had left meant he still needed 8 more pints to finish the next painting. Let's move on to word problem 3. Jack, Jill, and Bill each carried a 48-ounce bucket of water down the hill. By the time they reached the bottom, Jack's bucket was only 3/4 full, Jill's was 2/3 full, and Bill's was 1/6 full. So the question is, how much water did they spill all together on the way down the hill? So one might ask you to think just a little bit more. So take 3, 4, maybe 5 minutes, work on it, and then we'll come back with a solution that I came up with. Okay, I actually came up with 2 solutions. I'll show you the first one. In our first one, I drew little tape diagrams for each person. But first, let me go back. I want to make sure you highlighted the question. How much water did they spill all together on their way down the hill? And then we should have also highlighted that they each carried a 48-ounce bucket. And then Jill's bucket was only 3/4 full, or Jack's. Jill's was 2/3 full, and Bill's was 1/6 full. So in the first, let's talk about I drew 3 similar tape diagrams, one for Jack, one for Jill, one for Bill, and they all had 48 units, 48 ounces. So our whole is going to be the same for each tape diagram. However, what did we say? Jack's was 3/4 full, so 1, 2, 3. We don't know what that part is. Jill's was 2/3, so her tape diagram was broken into third parts, and 1, 2 was there, and so there's one part missing. And then Bill was only 1/6 full, so there's one part there, and then 2, 3, 4, 5, 6. So 5, 6 was the part that spilled. So what we can do it one way, we can say how much water was left in the buckets. Well, we know that Jack had 1, 2, 3/4 of 48. So when we multiply 3/4 multiplied by 48, we can simplify. And again, you should be getting pretty good at this. 4 will go into 48 12 times. So 3 multiplied by 12 is 36 ounces of water left in Jack's bucket. And then Jill, 2/3 of the 48 ounces were left in her bucket. So when we multiply 2/3 of the 48 ounces, we simplify again. 3 will go into 48 16 times. 2 multiplied by 16, you should have got 32 ounces were left in Jill's bucket. And then finally, Bill, he only had 1/6 of the water in his bucket. So 1/6 multiplied by 48. 6 will still simplify with 48. 6 will go into 48 8 times. And so we wind up multiplying 8 by 1 is 8 over 1. 8 ounces were left in Bill's bucket. But our question was, how much was spilled altogether? So now we have to subtract what was left, these amounts, from what they had. Jack, well, he had 36 of 48 ounces left, so he spilled 12 ounces. And Jill, she had 32 ounces left. That meant 48 and we subtract 32, 16 ounces left, and 48 and was what Bill started with. He only had 8 ounces left, so he spilled 40 ounces. Now, if we multiply or add 12, 16, and 40, 68 ounces. They spilled a total of 68 ounces. And that's one method for solving a problem. Now, you may have done another one. This next one is probably one that I would have been more inclined to use myself because it might have saved us one step. We knew Jack was 3/4 full. That meant that 1/4 of it spilled out. 1/4 of 48 would be the same as 1/4 times 48 over 1. 4 will go into 48 12 times. 1 multiplied by 12 is 12 over 1. So we know he spilled 12 ounces. Jill, 2/3 was full. That means she spilled 1/3. Let's find out what she spilled. 1/3 of 48 ounces. 1/3 multiplied by 48. Simplify again, and you should have got 16 ounces. Finally, Bill, if he was 1/6 full, that means he spilled 5/6 of 48 ounces. 5/6 multiplied by 48, we can still simplify, and we wind up with 40 ounces spilled by Bill. So we add again, and we wind up with our 68 ounces, and same total. They spilled a total of 68 ounces. Why don't you take a break here? Well, I'll tell you what, I'll introduce the next problem, then maybe take a break before you solve this one. Mrs. Diaz makes 5 dozen cookies for her class. 1/9 of her 27 students are absent the day she brings the cookies. She shares the cookies equally among the students who are present. How many cookies will each student get? Take a few minutes. Take a break if you want. These have been kind of a busy session so far. And we come back, you solve this one, and I'll give you the solutions that I came up with. All right, welcome back. Let's take a look at our problem and a couple of solutions. Okay, let's find out again, what were we being asked? How many cookies will each student get? And we know that she wants to share the cookies equally among the students who are present. So what else do we know? Well, we know she made 5 dozen cookies for the entire class, but we also know that 1/9 of her students are absent the day she brought the cookies. So now we have to figure out how many cookies each student got who was present. Method 1, again, we can go back to our trusty tape diagram if we want. We'll make one for the whole number of students. We know that total is 27. And we know 1/9 were absent. So we want to break our tape diagram into 9 equivalent parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1/9 was absent, which means how many were present? 8/9, right? 1, 2, 3, 4, 5, 6, 7, 8. So if 9 units is equivalent to a whole of 27, then we know that 1 unit is the equivalent of 27 divided by 9, which is 3. So if 1 unit is absent, then we know that we subtract those 3 students from the 27 total. We now know 24 students were present. We also know that 5 dozen is 5 multiplied by 12, 60 cookies. And we wanted to divide them among the 24 students that were present. So when we do that, we wind up with a fraction. It looks something like 60 divided by 24, 60 24ths. We can simplify that to 5 over 2, and then we can simplify that or change it to a mixed number, 2 1/2. So that tells us that 2 1/2 cookies were going to be available for each student. We can compare that now to the second method that I used. First off, we knew we had 5 dozen cookies. 5 multiplied by 12. Again, we established that's a 60 total cookies. We also knew 1/9 of the students were absent, which we should know. We can do that in our head. That meant 8/9 of the students were present. So if we know that we want to multiply 8/9 by 27 total, We can also simplify. 9 is going to go into 27 3 times. So that tells us that we have 8 multiplied by 3 over 1 multiplied by 1. We have 24 students present. And again, we take our 60 cookies, we divide by 24. 60 over 24 simplifies to 5 halves. 5 halves is equivalent to 2.5. So you should have had something that looked like a sentence at the end. You should have wrote, each student gets 2 1/2 cookies. Hopefully one of your solutions, if not both, if you did 2, looks something like this. Let's move to our last problem. I'm going to give you a little bit of a change of pace here. I'm going to ask you to create a word story. I'll create a story problem about a fish tank for the tape diagram below. And remember, your story must include at least one fraction. So you have a tape diagram, and we can establish that we know the hole is 84. What else do we know? We know 1, 2, 3, 4, 5, 6 units, but we're trying to find out what the shaded area is. So I'll tell you what, take a couple of minutes, write a fraction, and then we'll come back with what I came up with, at least for one plausible thing. There's a lot of different stories that can be here, but your numbers should be somewhat similar to what I do. All right, let's take a look at our solution now. You were asked to create that story about the fish tank. So we knew our hole was 84. So the first thing I said was, there are 84 fish in the fish tank. Then I said, since I knew that this diagram had 1, 2, 3, 4, 5, 6 parts equivalent in the hole, I said 4/6 of the fish are goldfish. 1, 2, 3, 4. And the rest are guppies. 1, 2. So the question becomes, how many guppies are in the tank? Now really, you could have stopped here. This is all I asked you to do, was create a story or something like this. And essentially what you wanted to do was create a story that told the whole and ask to find the 2/6 or 1/3 of the whole. And if you did the next step, I'll show you what mine looked like. And it was pretty simple. I took the tape diagram, and all we did was duplicate it. 1, 2, 3, 4, 5, 6 parts in the question. So now we knew we could find one part of it, or we could have multiplied simply 2/6 by 84, but I did 1/6 of 84. And 1/6 of 84, 6 will simplify with 84 14 times. So 1 multiplied by 14 over 1 multiplied by 1 is going to give us a total of 14. So we know each unit is going to be worth 14. And how many units did we have? 1, 2. So I simply multiplied 14 2 times and came up with 28. And then if we were to write a sentence answering our word problem, it would be there are 28 guppies in the tank. Again, I didn't ask you to do this. I would just be checking to see that your word problem resembled this and contained all our parts in the right sequence. And that about does it for our lesson today. I hope you had some success. And if not, you can always go back and review this. We have other resources, and you can find them in the learning guide. And I'd like to thank you for taking your time with us. We'll have one more. We'll have part 2 of the fraction review coming up in the next day or so. So until then, have a good day, and I look forward to seeing you again.